Here's something you probably don't think about every day. Beneath your feet, miles below the surface, lies an entire world we've barely begun to explore. Beneath this unassuming metal cover lies one of humanity's most ambitious and slightly insane project, the deepest hole ever dug on Earth. This is the Kola Superdeep borehole, a scientific endeavor that took 2 decades to complete and drilled an astonishing 12 kilometers into the Earth's crust. Drilling this deep into the Earth isn't something we do every day, and for good reason. Turns out it's really hard. Even with modern technology, we still don't have a quick and easy way to tunnel into the planet's depths. But that hasn't stopped engineers from trying, because if we can drill deeper, it might just change everything. A new wave of startups is working on methods to go beyond what was once thought possible. And if they succeed, we might be looking at a future where humanity taps directly into the Earth's heat, the geothermal energy. But before we get ahead of ourselves, let's talk about how this hole got here in the first place. Have you ever thought, what if I just kept digging? You know, straight down, past the dirt, the rocks, and whatever ancient artifacts Indiana Jones forgot about? Well, the Soviet Union actually did that. Right here, the Kola Superdeep borehole. This hole is deeper than the deepest part of the ocean. Deeper than Mount Everest is tall. In the 1970s, during what was basically the downward version of the space race, the USSR set out to see just how far they could drill into the Earth's crust. The United States, not wanting to be left out, also started drilling. But they pulled funding after reaching a measly 600 feet. The Soviets, though, they kept going for 20 years. By the time they stopped, they had drilled a third of the way through the Earth's crust. But what if you could drill all the way to the center of the Earth? Well, first off, you'd probably win a Darwin Award, sorry. Because as you go deeper, things start to change. The Earth isn't just a big solid rock, it's layered like an onion. The deeper you go, the hotter it gets. And not just uncomfortable hot, we're talking thousands of degrees. And even if you could survive that, what would you find? Let's peel the layers and take a look at what's inside. Alright, so let's say we actually do this. We step outside, grab a shovel, and start digging. As we go deeper, things start to change. By about 50 meters down, you might notice it's getting warmer. That's because the temperatures rise roughly 25 degrees Celsius per kilometer. Keep that in mind, it's important later. Right now, we're still inside the Earth's crust, the outermost layer of our planet. It's surprisingly thin, at least compared to the rest of the Earth. On land, it's typically less than 40 kilometers deep, which, to put in perspective, is shorter than a marathon. But as we dig, we're passing through millions of years of history. Fossils, layers of ancient rock, maybe even some long-lost treasure if we're lucky. And the deeper we go, the more impressive the structures we pass by. Humans have built some ridiculously deep things over the years. Alright, before we go any deeper, let's take a look at some of the most impressive things we've already built underground. For starters, there are research labs, like Kamioka in Japan and Sanford in the US, where scientists study neutrinos and dark matter. Because when you're dealing with mysterious cosmic particles, apparently the best place to do it is a mile underground. And we can't forget the world's deepest cave, Veryovkina Cave in Georgia, that plunges over 2.2 kilometers straight down. Imagine standing at the edge of that. No thanks. Then there are the deepest mines, like the Mponeng gold mine in South Africa. At over 4 kilometers deep, it's so hot that miners have to be constantly cooled, or else they'd literally cook. If you were just hanging out down here unprotected, well, you wouldn't be hanging out down there for long. So to keep going, let's equip ourselves with the ultimate, completely fictional Superdrill 3000, immune to heat, pressure, and all logic. At 12.2 kilometers down, we finally reach the deepest point humans have ever dug, the Kola Superdeep borehole. The Soviets didn't send people down here because they liked their scientists alive. Everything was operated remotely, using specially designed equipment built to handle ridiculous heat and pressure. They uncovered 2-billion-year-old fossilized microorganisms, and even water, at depths where scientists thought water simply couldn't exist. The Russians tried several times to get down past the maximum depth they had reached, but each time the new hole tended to collapse. They were so deep that the Earth itself was basically saying, nope, you're done. They called it a moonshot that will never be repeated or surpassed, and even that only reached 0.2% of the way to the Earth's center. That's barely scratching the surface. So, time to go deeper. At around 30 to 50 kilometers down, things start getting weird. The rock around us is getting denser and more compressed. We're officially crossing into the mantle. At first, it still looks like regular rock, but as temperatures rise above 1,300 degrees, the rock doesn't melt. Instead, it turns into something gooey. This is because the pressure down here is so extreme that even though it should be liquid, the rock stays in a bizarre plastic-like state. It's solid, but it flows, slowly over millions of years, creeping toward the surface in massive convection currents, which, by the way, is what keeps tectonic plates moving, causing earthquakes and shaping continents. But why is the Earth so hot in the first place? Well, it turns out the planet is basically a nuclear-powered lava ball. A mix of heat from radioactive decay and leftover energy from when the Earth first formed. And if you think 1300 degrees Celsius is hot, we're not even close to the core yet. The bad news is that it's cooling. But don't worry, we've got billions of years before it becomes a cold, dead rock. In the meantime, all that stirring magma soup inside our planet is constantly moving huge amounts of heat from the core toward the surface. And that's kind of important. It drives everything from volcanoes to plate tectonics. But wait, how do we even know this? Humans have only ever drilled 12 kilometers down. That's barely a scratch on the surface. So how do we know what's happening thousands of kilometers below our feet? Studying the deep Earth is basically like being a detective, but instead of solving crimes, we're solving the biggest geological mystery of all time. Since we can't go there, we have to rely on indirect evidence. That would be seismic waves, magnetic fields, and the occasional chunk of deep Earth rock that gets blasted up in volcanic eruptions. But the ancient people had some interesting theories. Some thought the Earth contained a central fire, with massive underground lakes and lava chambers. Others believed the planet was hollow, with multiple concentric layers, each one potentially housing entire civilizations. Yeah, people actually thought that. Isaac Newton suggested that the center of the Earth must be way denser than the surface, based on how gravity works. But for a long time, we couldn't prove it. It wasn't until the early 20th century that scientists finally figured out that Earth wasn't just a big ball of rock. It actually had layers. These discoveries wouldn't have been possible without the seismic activity. When an earthquake happens, those seismic waves don't just shake buildings, they go down through the Earth. And here's the cool part. There are two main types of seismic waves, P waves and S waves. P waves can travel through both solids and liquids. S waves can only travel through solids. And because they move differently depending on what kind of material they pass through, scientists realized they could use earthquakes to X-ray the entire planet. By measuring where these waves show up on the other side of the planet, scientists figured out there is an S-wave shadow zone, a place where S-waves just stop, because something down there is liquid. That was the smoking gun that told us Earth isn't just a solid rock all the way through. Instead, it has a massive liquid layer, what we now call the outer core. And we just crossed into it. This liquid soup of molten metals is cooking at a ridiculous 4,400 degrees Celsius, hotter than the surface of the sun. And it gets even crazier from here. Okay, so now we're in the core and things are getting wild. At this depth, temperature finally beats pressure and we enter a swirling molten ocean of metal. And here's why this hot metal soup is the most important thing keeping us alive. All that constant churning of liquid iron and nickel generates massive electric currents, which in turn create Earth's magnetic field. And life couldn't survive without that. Without the magnetic field, cosmic radiation from the sun would strip away our atmosphere and pretty much fry everything on the surface. But here's where it gets even weirder. That magnetic field sometimes randomly flips. Yep, the North and South poles just switch places. And we know this because, get this, according to scientists from MIT, there's basically a barcode for Earth's magnetic history printed on the ocean floor. As basalt lava erupts along mid-ocean ridges, it cools and locks in whatever direction the magnetic field is pointing at that time. Then, as new rock forms and the plates pull apart, they leave behind a perfectly preserved record of every time the field flipped, which turns out has happened a lot. It flipped here, and it flipped here. The last reversal happened 780,000 years ago. And when will it flip next? Well, we don't know. But that brings up an even bigger question. Why does Earth even have layers in the first place? You're gonna like this one. At the beginning, Earth was basically an angry giant ocean of magma. And in that chaos, all the heaviest stuff, mostly iron and nickel, sank to the center, Meanwhile, the lighter stuff like silicon, oxygen, and all the fun minerals that make up our crust floated to the top. This process, called planetary differentiation, is the reason why Earth isn't just a homogeneous blob. Instead, we ended up with distinct layers separated by density. Okay, finally we're deep inside the outer core. And then, we hit something. At the very center of our planet, there's a solid ball of metal, and it's almost as hot as the surface of the sun. For a long time, scientists assumed the entire core was molten, because why wouldn't it be? A couple of scientists studying seismic waves noticed something was off. When waves reached the deepest part of the Earth, they started acting weird. Waves were bending and reflecting in ways that shouldn't have been possible. The math only made sense if there was a solid ball inside the larger liquid one. And sure enough, after decades of research, better computational models, and more precise earthquake readings, seismologists finally confirmed it. The Earth's inner core isn't just molten metal. It's a solid, superheated ball of iron. Turns out, at this depth, the pressure is so ridiculously high that the iron atoms literally can't move. The metal stays locked into a solid state, despite being at a temperature that should absolutely melt it. And if that wasn't weird enough, scientists have found even stranger evidence that the Earth's core is rotating at a different speed than the rest of the planet. It's speeding up and slowing down completely separate from what we're doing up here. Super precise seismic data and advanced computer models of our magnetic field show that the inner core follows a roughly 70-year cycle. Every few decades, it slightly accelerates, then slows down again. And you might have seen some recent headlines saying, Earth's core is reversing. Yeah, that's not exactly true. Imagine you're standing on the inner core, and I'm up here on the surface. If you slow down, from my perspective, it might look like you're moving backward, even though we're both still spinning the same direction. Okay, so we finally made it to the very center of the Earth. We are now 6,400 kilometers from the surface, officially at the very center of the Earth. The pressure here is 3.6 million times what it is at sea level. The temperature is approaching 5,700 degrees Celsius, basically hotter than the surface of the sun. But we still don't know exactly what's down here. Most of the interior is still a mystery, especially the center. Some scientists think there might be an inner core, a second, even smaller solid core at the absolute center of the Earth. New seismic data suggests that deep down, the iron atoms might be packed differently than the rest of the inner core. But as we get better at reading the clues hidden deep inside our planet, we're becoming better detectives. But there are still so many questions. Can we predict when Earth's magnetic field will flip? Could there be entirely new layers waiting to be discovered? Right now, scientists are running massive experiments using seismic wave simulations, high-pressure labs, and next-gen supercomputers to unlock more secrets of the deep Earth. But despite all the work that has been done, we're still just scratching the surface. The deeper we look, the more we realize that we barely know it at all. So maybe one day we'll build the technology to dig even further, to break past that 12-kilometer limit and finally see what's really down there. And with that, hit the bell icon, stay curious, and I'll see you next time.